Okay, hi guys, so we'll be seeing more on processes. So next we'll be seeing quasi-static process. Oops. So quasi-static process is a process if it is carried out in such a manner that every moment system departs infinitesimally from equilibrium state, then the process is called quasi-static. So if process is carried out in such a manner that every moment system departs infinitesimally from equilibrium state. Okay, next let us see state function and path function. So state function is a measurable property of a system that does not depend on how system gets from one state to another. Is a measurable property of a system that doesn't depend on how the system gets from one state to another. Okay, which means that state functions are path independent. Okay, and change in state function has a fixed value if we define its initial and final state. Change in a state function has a fixed value if we define the initial and final states. Okay, example of the same can be pressure, volume, temperature are all state functions. Okay, internal energy is a state function because on integrating dt we can write from initial to final, we can write it would be equals to delta t, and delta t would be written as tf minus ti, or t final minus t initial. Okay, similarly for delta u or du from initial to final stage, we can again write it would be equals to delta u, which would be uf minus ui. Delta u is nothing but change in internal energy. Okay, next let's talk about path functions. So path functions are those that, so for example, heat and work are path functions. And what exactly are the path functions? So the the functions whose value depend not only on the initial and the final state, but also depend on the path of the process. So the value of path functions depend not only on initial and final states, but also depend on path of the process. Okay, as in how the process is carried out. Okay, next more examples of path functions. As we already know that W and Q are path functions, wherein we can write that d of dw from initial to final for a path, specific path, would be equals to W, and which would not be equals to delta W, which would not be equals to Vf minus Vi. Okay, and dw in this case is an inexact differential okay. Similarly, we can write dq for I to f for a particular path would be equals to q. Okay, so with this we come to the end of this lecture. In the next lecture we'll be discussing on total and internal energy of a system. So till then, good luck and goodbye.